The effect of red cell distribution of red blood cell at different days after minimum and maximum exposure to ultraviolet and X-ray radiation. By me myself, Amirul Ariff bin SAIFULDDIN, my supervisor Abdullah bin Muhammad Noor, and my co-supervisor Aiman Afif bin Roslan from Faculty of Health Science, University Selangor. As for introduction, due to the indirect nature of processes of cellular harm brought on by high-dose X-ray radiation, these alterations are further affected by radiation. Based to the data, cold stored blood can withstand up to 75 gray of radiation without significantly changing crucial characteristics and thus still appropriate for use in vivo. Ex vivo measurement of fresh and cold stored blood parameter are radiation after radiation help understand in vivo effect of radiation on blood or blood vessel system and gauge the sufficiency of stored blood following radiation exposure. We examine how exposure to radiation affect erythrocyte ultrastructure, cell shape, and electrolyte during storage. In this investigation, we discovered that irradiation of gamma rays might affect erythrocyte shape and plasma concentration of the ions sodium, calcium, and chloride. Fraction of normal erythrocyte fell after irradiation, whereas the number of aberrant one rose. Echinocyte, spherokinocyte, and degrade form made up the majority of the aberrant erythrocyte. These cells are typically seen in people with hemolytic anemia, acanthocytosis, and liver disease. Inadequately prepared slices may cause normal erythrocyte to change into acanthocyte. So, as we all know, red blood cell is a metabolic. As we all know, red blood cell is important to our body as it carry metabolic waste away from the cell as well as essential element like nutrition and oxygen. The main function of blood is to carry oxygen through the circulatory system from lung to the organ in exchange for the carbon dioxide from the organ to the lungs and to be expelled from the body. Red cell, as for red cell distribution, they are divided into two categories, which is agglutination and roulette formation. As for agglutination, it is the clumping of red blood cell and it occurs when antibody attach to the antigen on the surface of the RBCs. Meanwhile, for the roulette formation, it is the stacking or aligning of red blood cell into columnar structure. As for X-ray, it is electromagnetic radiation type that resemble visible light. However, X-ray have higher energy than light that can penetrate more solid material including the human body. X-ray are ionizing radiation that is used for the image of patient's bone and tissue. Ionizing radiation has enough energy to break a cell, causing DNA damage and the production of free radical in the process. Ionizing radiation has the ability to destroy living tissue, and this is a danger that gets worse the more exposure someone has over the course of their lifetime. Next, as for the ultraviolet radiation, it is a wavelength that is longer than X-ray but shorter than visible light. UV radiation has the ability to interact with organic molecules that has several practical implications during chemical and biological impact. DNA is harmed by the short wave of UV radiation, which also sanitizes surface it comes into contact with. The consequences of skin exposure to UV radiation on humans include a sunburn and as well as a higher chances of developing skin cancer. This is my objective for my research, which is for general objective to investigate the effect of red cell distribution of red blood cell at different days after minimum and maximum exposure to ultraviolet. And for my specific objective, the first one is to the amount of ultraviolet and X-ray dose that give impact to the blood morphology. The second one is the correlation of the morphological changes in the blood that give rise to the hematological conditions. As for my methodology, it divided into 5 steps, which is the first one is for blood taking. For blood taking, we take 5 ml of blood from 5 participants and divided into 5 different tubes, which is the first one, control, UV 5 minutes, UV 10 minutes, X-ray low and X-ray high doses. The second one, after we take the blood into the test tube, we expose the blood to the UV 5 minutes, 10 minutes, and also to the X-ray radiation, which is for the minimum we take 70 kVp and for the maximum is 90 kVp. After that, we smear the blood. To and make a thin layer to see what is the changes in the blood characteristic, and after that we review the smear under the microscope, and lastly we repeat the steps for 3 days and tabulate the results. As for the result and discussion, this research has shed light on the impact of UV and X-ray radiation on the biological system, but a significant gap remains in our understanding of how exposure duration affects the red cell distribution. Among all the samples, sample 4 stands out as it revealed the most significant findings when exposed to both minimum and maximum level of ultraviolet and X-ray radiation. Notably, in sample 4, progressive results were observed on each day with an increase in the formation of roulettes and the appearance of agglutination on day 3 of the UV exposure for 5 minutes. These findings are supported by similar trend observed in the other samples. Nevertheless, it is important to acknowledge that the limitation of this study from issues related to blood smear preparation skill, sample handling, and the field of view during microscopic blood smear analysis. As we can see here, in the control sample 4, the appearance of roulettes can be seen in the smear. However, if you see in the UV 5-minute sample, there is increment of roulettes formations, and also there is a agglutination formation appear in the slide smear. As for the conclusion, as a result, the research on the impact of red cell distribution at a various time after minimal and maximal exposure to UV and X-ray radiation emphasized the intricate relationship between radiation exposure and hematological parameter. It is clear that both forms of radiation can have influence on how red cells are distributed within the circulation, even if the particular results may vary depending on the experimental setup and the amount of time after exposure. Thus, based on the data analysis and the results, all objectives are successfully achieved, and as a conclusion, there is a numeral amount of effect on the red cell distribution caused by the ultraviolet and X-ray radiation. As for my reference, this is my reference for my research based on the past study regarding blood and radiation. That's all from me. Thank you.